Ever wondered how to calculate molecular mass or determine empirical formulas? Today we're going to unravel these mysteries and more with some basic chemistry concepts. First off, let's talk about molecular mass. Take water, for instance. Its chemical formula is H2O. To find the molecular mass, multiply the atomic mass of hydrogen by 2 and add the atomic mass of oxygen. The result is approximately 18.02 units. Similarly, for carbon dioxide or CO2, multiply the atomic mass of oxygen by 2 and add the atomic mass of carbon, giving us a molecular mass of approximately 44.01 units. For methane or CH4, multiply the atomic mass of hydrogen by 4 and add the atomic mass of carbon. This gives us a molecular mass of approximately 16.043 units. Moving on, let's delve into the mass percentage of elements. Take sodium sulfate or Na2SO4 as an example. The molar mass is calculated by adding the atomic masses of all its elements, which equals 142.066 grams. Now consider an oxide of iron with 69.9% iron and 30.1% dioxygen by mass. The empirical formula of such an oxide can be determined with these percentages. Next, let's calculate the amount of carbon dioxide produced when carbon is burnt. For example, when 1 mole of carbon is burnt in air, or in 16 grams of dioxygen, or when 2 moles of carbon are burnt in 16 grams of dioxygen, the amount of carbon dioxide produced varies. Furthermore, to make a specific molar aqueous solution, such as 0.375 molar of sodium acetate, we need to calculate the mass of sodium acetate required. For instance, for a 500 milliliter solution, we'd need approximately 15.38 grams of sodium acetate. Finally, let's calculate the concentration of nitric acid in a sample with a given density and mass percent. By doing so, we can find the number of moles in a specific weight of nitric acid. In summary, we've learned to calculate molecular mass, determine the mass percentage of elements, establish empirical formulas, calculate the amount of gas produced in a reaction, figure out the mass required for a molar solution, and calculate the concentration of an acid in a sample. Remember, practice makes perfect. Keep practicing these calculations, and soon they'll be second nature.